we will have some introduction first. And who is Mary? I'm a streaming developer advocate at DataStax, and this is a company based in California in the US. And how many of you actually have heard of Apache Cassandra or using it, right? Oh, so quite a few, actually.
Wow.
Any of you are maybe using DataStax, DSE? Oh, yeah, actually, it's a couple too. Great, awesome. So let's connect too. Okay, so that's DataStax, that's where I'm at, but I'm with the streaming team. Previously, I was with IBM. I was also a developer advocate there. So I've been doing developer advocacy for about 4 or 5 years now. And then I'm based in Chicago. I'm also the president of the Chicago Java Users Group. And also, I'm the Java champion too, and basically an active community builder. Before becoming an advocate, I was a developer like yourself. A lot of you are doing development mostly in Java, open source, and cloud and DevOps kind of work. So I understand what normally if you do engineering, the day-to-day thing, I understand very well, and I kind of enjoyed that too myself. But now I'm doing advocacy work. So okay, and then the next thing, next item is Daniel introducing himself.
Hello everybody, I'm Daniel. Oh, so just a quick question. How many people actually joined my session 1.5 hours ago? Oh yeah, okay. It's a pre-work to introduce myself.
Sure.
Yeah, my name is Daniel. Oh, I'm based in Boston, United States. And I actually met Mary in Chicago and then another Java conference. And we actually joined the workshop stuff, like a Kubernetes and then Java application, things like that.
Yeah.
I'm working for Red Hat as a developer advocate, like a Java space, and also CNCF ambassador, like a managing or hosting like a KubeCon and then like a Kubernetes community day, and then provide a more example and then practice to bring your application into Kubernetes and ecosystem, like observability, OpenTelemetry, Kubernetes Prometheus, and things like that. And I'm going to spend a lot of time to bring more Java application into some of the use cases in terms of serverless service mesh, and then GitOps, Argo CD, things like that. Yeah, here's my contact information, just like Mary, Daniel030, like Twitter, and then YouTube, and then GitHub repository. Yeah, feel free, reach out to me anytime if you are interested in some stuff, and I'm more than happy to help.
Yeah, okay, thank you. And so, yeah, again, too, it's interesting, right? Just give you some background why we decided to come together and do a talk together, because as Daniel mentioned, we presented a workshop together at, was it JConf, right? That's a Chicago-based conference called JConf. And that was all virtual. That was during COVID time. So we actually had fun. We did something, I think, with microprofile and, and Kubernetes with OpenShift, too. And so we thought, well, it would be nice to do a talk together again. And now everything's back to normal. We can travel. And we're very fortunate and kind of thankful we got selected for GITS here for Developer Summit. So, and here it is today. And because we work on like different areas of our products, and that we definitely we're seeking like opportunities to do collaboration projects together. So this is just an experiment that we are experimenting with.
Absolutely.
And all these are modern, like cloud native type of technology that really is meant to be, easily integrated with one another. So we like to do this and present to you. So thank you. And so with that, we'll start. Today's talk, we'll first start with some basic like concepts first. As such, right, we're talking about event streaming, and we want to basically introduce event computing, just assuming not everybody is familiar with event computing yet. But I know, too, there are folks who might have come to my previous talk yesterday. And my talks too yesterday were all about event streaming, about Apache Pulsar. May I ask how many of you came to my talks yesterday? Yeah, okay, so quite a few of you. So please excuse me if I'm repeating some things, because maybe not everybody, again, have worked with event streaming type of applications. So I like to make sure, giving some background information first. So, okay, so let me kind of start first. So what is event computing, right? And there's also the traditional computing. Basically, if I want to describe it, there are many ways of describing it. If I search on the internet, I found out there are also a variety of different ways of describing event computing. And it can be confusing too. Maybe some of you are maybe new to it. Maybe you first learned it too. I mean, as such, because I found out there are so many different ways of interpreting or just different angle looking into event computing, it can be confusing. But the way I like to kind of describe it is basically, if I summarize, I would say is computing that mimics kind of closer to the human conditions. I think if I summarize, if I had to if my grandma asks me what it is about, right? Or like somebody who isn't familiar with computers, I'll say this is a way to really mimic the human way of interaction. And basically, too, how we live, if you kind of go into that, is basically, if you think about how we live, too, is pretty much our lives are centered around events, like different types of events. Can be events that's kind of a baby is born is an event, right? And
life event.
Yeah, life event,
yeah.
And a concert, right? Going to a concert is an event, and going to a soccer game is an event, a cricket match, right, here in India. So those are kind of events. But as you notice, too, events, too, are interesting. If you kind of start to think of it, and how do we do computing to, essentially, right, doing computing is to make our lives easier, to design applications that can help us day to day. So now we want to do development, do implementation, and designing systems that can help us. So we want to have these systems mimic how we, handle interaction every day. And so essentially, too, for events is basically dealing with, asynchronous style of processing. Yeah, like if you think about it, right? How many of us would be talking to someone and we want to do something? I say, hey, Daniel, I want this, and I just sit there and wait for Daniel to get to me. That wouldn't happen, right? In reality, it's like, well, Daniel, can you get this for me? And then in the meantime, I might go and do something else, right? And so essentially, that's what we're trying to do in event computing, is that we want to be able to have some, request, so to speak, right? And or maybe not even like active requests. It can be something that happens that trigger and some actions to be done. Essentially, that's what we're trying to do. And so some actions that will trigger responses, and that's what event computing is all about. And it's very much asynchronous, and there's no waiting around. We don't want to waste time. We want to be doing, we are all multitasking today. We want to do one thing right now while we're also handling many things at the same time. So that's it, essentially, that's what it is, right, without any kind of technical interpretation to it. And the thing is, too, with event computing, is basically the data is basically the centerpiece of attention here. With all the events, then it carries with it like data, right? So it's the data that's basically of interest, because essentially, too, if any kind of events that happens, it will cause the change of the state of these data. And that's what we're interested in capturing whenever there's events and, some event that happens. And also notice, too, all of these events are meant to be like immutable. Once some events happen, you cannot change it anymore. It's there. So we want to have, facilities to also capture all of these events, being able to go back and trace them, trace back that type of stuff. So data is what we're dealing with. And essentially, too, event computing is very much, too, when we start to bring in technical terms, is really about messaging. We're relying on the messaging infrastructure to help us to do eventing type of work, because any kind of events happen, you trigger some action and some data change of state, right? That's what it is. And what other things? So basically, too, one thing, too, about doing event computing, while it is, mimicking the real life scenario, it also presents a lot of challenges, as we know. It's not as easy to do as traditional type of style of programming. Essentially, too, the main thing is that basically event computing is harder to kind of grasp in terms of what type of pattern is it doing. The kind of pattern, too, is kind of subtle, too. It can be happening at any time, and it's harder to trace, and that's what the challenge is. So to summarize, event computing, that's what it is.
Yeah, there's one observation, actually.
Sure.
So whenever you try to search for event computing or event related some technology term, like Google searching, or even if you're going to ask the ChatGPT, and then you find some relevant like a functionality or a characteristic, what do you call that? It's like the scalability, reliability, and then like some storage stuff. That's really may explain some data is a key critical area when you they handle like events computing stuff.
Yeah, totally. Yeah, thank you. Yeah, exactly. So, okay, so then maybe conceptually, let's also try to look into comparing event computing with traditional computing. So if we kind of compare the two, over here, I kind of lay out, briefly. So event computing is really about more non-blocking style of, asynchronous style of processing. And then whereas traditional computing is really dealing with synchronous style and blocking, more like blocking. But think of the fact that when we first started learning how to program, actually we kind of follow more of the traditional way of doing things, right? And we are writing code that is more a request response type of pattern. You issue a request and you sit sort of, so to speak, like you wait for it, right? And for the processing to come back, and then the result comes back, you're happy, then you take the data and move on to the next step. That's what essentially we're kind of doing, more used to, our minds are more used to training ourselves to think like that in terms of when we get to doing computing work. And the thing is too, if you look into it, then with event computing too, the data, as Daniel also pointed out, it tends to be, their data is important, but also tends to be less structured in some ways too, because we're relying on some messaging to carry messages as payload too. So it's kind of a different way of thinking. Whereas like for more traditional computing, when we learn about things that, we're maybe working with database, especially with the older systems, right? Like mainframe, in fact, the data has to follow certain rules, right? That even the size, it matters and all of these things. So it's a bit more rigid, as you can see, the traditional way of doing things. They may be easier for human beings to understand, but it doesn't quite serve the purpose of us living in a fast-paced world now. Everything's about real time, that type of thing. So, and also too, another thing about event computing is it's really about sort of separation of concerns. We have so many components in our systems. The decoupling side is also very important too. Nothing is very tightly coupled. And so traditional thing tends to be, you send a receiver, you could be on the same, component too, in fact. But the thing is with event is everybody is independent. You move around independently, very decoupled. So that's why too, for example, like event computing, a paradigm or kind of semantic patterns we like to use is a publish, subscribe type of pattern. You have sender, receiver sending messages, but you don't really care who you send to, and you just send the messages out. And if you're interested in messages, you subscribe to the topics, and so the broker will deliver the messages like that. So, and essentially too, events basically is something that happens. The events will then trigger this flow of the data, so to speak. Whereas like for traditional computing is the request, you send a request and maybe then initiate the flow of execution. So then all of these steps are pretty much sequential, is more predictable too for a traditional way of doing things. But events though, it tends to be unpredictable because you can be sending messages out asynchronously, and different messages get processed, at different rates. So you get back results in different times as well. So we have to be aware of that. And what else? And basically, yeah, I think pretty much. And so essentially, if we do event computing, we have to be aware of, when we do debugging, tracing will be harder. It's just in general, that's what it is. But I think in today's, like a lot of framework too are kind of also built in with better observability tooling, right?
Yeah, sure. And then one observation, if I may, so as a developer standpoint, so what is the matter of this kind of event computing versus traditional computing? So for example, you are, let's say you are a Java developer, you've been doing a lot of stuff like a Java EE maybe decades ago, and then now you're going to pretty much focus on Spring Boot application, and then you just writing code for like a not reactive application, not related to event-driven stuff. So you just develop application and then process like a HTTP protocol and request response thing, and then pretty much synchronize your data transition, etc. However, something came up like event-driven computing. Some of your another team, like infrastructure team, just decide, okay, we're gonna go move forward to like event computing on top of the cloud. And then that also trigger your application architecture and portfolio and even application functionality as well. So for example, like I mentioned earlier, Spring Boot. Okay, now I need to rewrite my existing Spring Boot application to Spring Reactive, which is a totally change your daily life. When your company or organization decide going to event computing, and then you need to just not care about human being, like some triggering, but also maybe sometimes some IoT edge devices call your reactive application or from cloud environment or something else. So it's all kind of various events coming to your application, which means that you need to maybe redesign, re-architect, and rewrite your existing application regardless of the Java, .NET, Python, and even inside the Spring Boot ecosystems.
Yeah, that's right. Yeah, thank you. Yeah, okay. So I hope that kind of has set the stage for our discussion that comes after. So the next thing we're going to talk about is basically applying event streaming type of techniques. So basically, when we get into event computing, yesterday I did a talk on more of an art and benefits of event computing. So some of you might have been to my talk there. So I kind of showed the same slides too, but essentially just wanting to touch upon these different terms, because as we kind of, when we're discussing about, setting up this talk,
Yep.
we're saying that it can be very confusing. You can be have done computers
Absolutely.
for a long time, right?
Yeah, so
Yeah.
some of the people actually joined my session previously, and then I actually kept saying a few different terms interchangeably. For example, event streaming, event storming, and event-driven messaging. So a lot of people actually use those terms interchangeably whenever they develop like a reactive application on Java, and then connect to like a backend, like a Kafka server, Apache Pulsar, or even a messaging broker. So, but maybe one question for Mary. So can I use that kind of technology term interchangeably? And is that all true, or are there some big difference among those technology? And even if whenever searching event storming or event computing, maybe serverless application just came out because the serverless actually invoked by some trigger, which is some of the event from like a RESTful API or IoT devices or some human being, and you select on some mobile your phone.
Yeah.
So maybe you got to give us some insight. What is the difference among these terms?
Sure. Yeah, that's a very good question, and I've asked too. And basically, too, let's say, right, you have some older applications and you want to try to modernize it, right? Say, I actually got asked by someone, I don't know, I think Kumar, who was asking me yesterday about, he was saying that he's using some older messaging middleware, and then they still need to get the messages. So they send the messages to some topic. So once you get the topic, you want to have that kind of start to create a modern data flow. Downstream, right? And essentially, too, I believe you should be able to, and nothing should be preventing you from doing that, but it kind of does require a bit of thinking. You can have some older architecture, but again, the data is basically the core of your interest. So the data, you can capture it into some, like, say, topic, like, again, right, doing a topic, then you can actually have a modern pub-sub type of way of subscribing to these topics and get the messages, and then essentially do transformation as well, such as like using Pulsar. If you're using a Pulsar event streaming platform, there's also, you can leverage on Pulsar functions that you can use to transform your messages too. That comes in, you need to filter, for example, filter the messages, or basically you can be getting some messages that you need to do further processing, that you can basically maybe use Cassandra, do some database lookup, right, using some data. You can do that within like a Pulsar function. Then after you transform the data, you can then output it to a sink, right? A sink is essentially where you collect the output from your transformed data too. And then so on and so forth. You can essentially turn that output sink into another topic. So that topic becomes another source for another pipeline segment that you can build too. So I think you can certainly do that.
Yeah.
And then with serverless applications, it's interesting, I think, and that's the area that Daniel is really expert in now. So yeah, so serverless, I believe it's also, let me turn around, right? Is it normally, it's kind of applied, you use events kind of way of doing
absolutely.
serverless, right?
Yeah. So one of my talk, actually, I prefer to use Apache Kafka and then KNAV eventing, which is really you're going to invoke your serverless application based on events.
Yeah.
Events, just like I said, from like a RESTful API in the other application, or when you just select some of the menu on your mobile application, or some of the connect to like some IoT devices, things like that.
Yeah, sure.
So maybe you just remember or remind some very old technology, maybe 10 years ago, there were huge popular like some service-oriented architecture, like AKA SOA.
Yeah,
and after
SOA.
10 years, and then some people just talked about, oh, we have a new fantastic stuff like MSA, so microservice architecture, but you already have some experience SOA. It's a pretty simple, pretty similar thing. Yeah, and then there are many things similarly, like a benefit and a characteristic and some tools and a framework how to implement SOA versus microservices. But thing is, we can say it's 100% same. It depends on the what kind of platform, like a cloud, and then like a performance, and then like some capacity. So you need to choose the right tool. So that's what we're going to talk about a little bit more Apache Pulsar and then some kind of Java framework today.
Yeah, that's right. Yeah, and one note too I'd like to ask. I think for serverless apps, it tends to be, it means that you don't, as developer, you don't need to worry so much about infrastructure, right, in a cloud type of way. Yeah, so so that's what it means. Okay. All right, that's good. Yeah. So, okay, so I hope that also clarifies, is it good? Our time is good, right? Okay, so like I said, we're just wanting to touch upon these. And today too, let me kind of talk a bit more then about event streaming, because maybe not everybody came to my other event streaming talks before this. So let me point that out. First of all, right, we are talking about streaming. Streaming as such, right, I'd like to also point out is that there's also, the streaming, this term is also being used, in media. Video streaming, like your music, your phone, like everybody is listening to music that's live stream, right? So that's also streaming, yes, because it describes like streams, kind of essentially data that flows through, in time and space, and that's kind of event, it's streaming. But the difference is that, like when we're talking about using Kafka or Pulsar, this kind of event streaming tool is more for just data type of processing, not like for media type of streaming. The reason is that for media like audio and visual and video, those actually, the data frames, if you kind of get it down into some basics, these frames all comes in, right, travel through wires. But on the assembly side, you do need to make sure that they are processed synchronously, because all these, the frames needs to be in order. Otherwise, if you're listening to the music, then it won't come out correctly. Or if you're watching a movie, the frames are wrong, right? So it's different too. So when we're using Apache Kafka and Pulsar, we don't use it in general, right? We cannot actually use it to apply to do video and graphical, or what you call it, visual or video streaming type of thing. So that's the one thing I want to point out. So, okay. And so now, then we can kind of look now, the next thing too is basically, with this event-driven world, right, the kind of use cases that we can think of using. So here, it's just like a generic picture that's showing that the types of applications that you can use to utilize streaming. So as you can see over here, they're kind of, this is kind of high level, looking at all the possibility. Basically, the possibilities are limitless too. It's kind of really, it's only limited by your imagination. But as you can see, in a business world, basically using it for manufacturing, there can be many types of applications you can think of, maybe some manufacturing automation that you have certain type of timing that certain things can happen. You want to automate that and doing notification, right? That will be some kind of example of that. And then there's also financial services. We can think of it like in many different ways as well. And today we just have a simple example to show you is like using trading match kind of the trade match engine. That's kind of more of a financial investment type of services. And then there's also basically using streaming for events-driven type of architecture. And also one area to another area is basically in the security side of things, right? Security, enterprise kind of communication, it all requires like security, a lot of monitoring, making sure there are no hackers or no suspicious activities, and you need to take action on any kind of data that looks suspicious to you. So like, for example, like threat and fraud detection, if you do need to like then deploy processes that are there to monitor your bank accounts, your investment accounts, and making sure that it isn't, kind of any kind of hackers doing anything, kind of causing suspicion. Yeah. And then there's
this is really interesting because I got a lot of asks from customer and then even developers because they're looking forward to some reactive programming with the event-driven architecture. And then the first question probably, so what kind of business logic and application I need to modernize from non-reactive to reactive based on the event-driven architecture like Apache Pulsar or Apache Kafka, things like that. And then this diagram actually showcases it's pretty much everything.
Yeah.
So, and then in the serverless use cases, it's the same. Some of the people ask me, hey, Dan, what kind of application I can change it to like running all the time to like a serverless application? I would say it's pretty much everything.
Yeah.
As long as you can have some relevant event to like trigger your serverless application. So I actually, just right before this session, I asked this one question to ChatGPT. So what is the use case, what are the use cases for adopting event-driven streaming? And the ChatGPT actually answer pretty much the same thing or the use case like financial services and security, healthcare and manufacturing, and any kind of web application and mobile app, and even like some your house and building automation like as a part of the IoT and even AI ML.
Yeah.
So this is wholly true.
That's
So you can adopt for event-driven technology in any kind of application, as long as you're gonna have some willingness to process the real-time like some traffic.
Yeah, that's right. Yeah, essentially, yeah, the key is using event streaming, it helps you with real-time type of processing. So that's like a big advantage of why you want to use event streaming. Okay. And here too is basically another like a diagram. It's a little bit, a lot of things in here, but I'll just kind of pick one thing. So these are sample application usage scenarios. Basically, in this particular case, I'm using my company. If you can use other solutions too, but of course, my company has all these tools for you to use, which is our managed cloud Astra streaming platform. And then also either if you want to deploy it yourself, it's called Luna streaming. So essentially, it's using Apache Pulsar underneath the hood.
That image actually doesn't show here.
It doesn't show. Oh, yeah, the screen. Yeah, sorry. Okay. Yeah. All right, that's fine. But I just want to kind of take a quick run through some of it, right? And we still have some time. Okay. So basically, you can use it for like customer web portal. You can do that, and order processing, warehouse shipping, inventory management, all these things, right? These are kind of very common kind of applications that we build at our workplace, especially. But I see, let me highlight, right? See an order processing over there, and the second one, right? The order, yes. Actually, this thing doesn't work too because I think on the left. Sorry, but that's okay. The order processing. So essentially, too, you can have order processing that are generating orders, right? So if we look into it, too, the second one, order processing, they will process the order. It's basically, it comes in, right? And you can make use of the producer-consumer type of facility to help you to take the order in. And essentially, too, over here, it sends out all of these warehouse type of shipping requests, right? It's, again, you're dealing with, within your system, within your company, if you're doing order processing. It comes in, and then you need to then process the order and then send it over to another department, let's say to process shipping requests, checking whether your catalog has what customer is requesting for, that type of stuff too. So yeah, so essentially, pretty much, yeah, you can kind of use event streaming to help in your internal type of system or even external type of system. I think that's what I'm trying to be talking about. So yeah, it's just harder to show over there. Oh, now it works. How did it work?
Yeah.
All of a sudden it
so
showed.
Don't worry, we're going to share a slide there and right after. Yeah.
Okay.
Yeah. You can take a look at that.
Okay, we'll
after
look
session.
at that. Yeah. Okay. All right. Just want to make sure I leave time for getting into the choice of tools section, because then you're going to be telling us about exciting tooling. But first of all. We talk about event streaming, so I already gave you a hint. I just want to touch a bit too on Apache Pulsar. Apache Pulsar, it works like what Apache Kafka is doing, is a distributed messaging system, right? And the difference is that Pulsar, right, was developed came out a little bit after Kafka came out. And the reason was that the people at Yahoo, the engineering team, they decided that Kafka could not meet their needs, and that was back in 2010, 2012, that time frame, because Yahoo was already using cloud to manage their huge data sets and all of these things, and they figured that they figure out that in a cloud native type of environment, Kafka cannot operate as easily. There's a lot of manual steps you need to do. For example, if you add a node to your infrastructure, add a server, all of these things, your topics are already partitioned, and you need to do manual kind of spreading out your topics again, and all these other things, right? They're kind of more infrastructural type of concern. They found out it's not as easy to do. So Yahoo engineering decided to design a new, better message logging system that can function better in a cloud-native environment, and that's when Pulsar was born. So in 2013, they came out with Pulsar, but it was initial stages, so they donated it to Apache Software Foundation in 2016, and then quickly became a top-level project. And the differentiation of Pulsar over Kafka is that it adopts a very cloud-native design, and it's very much a cluster-based system to start with. And also another feature is the multi-tenancy. So it helps too. The multi-tenancy meaning that all of your messages are all being like, organized too internally. The way you design is kind of organize it by tenants. So that already is native to it that way. It's easier for you to organize all of your messages, right? And you can, for example, in an organization, you have different teams that you want to have different messages that are organized by teams. So you can already leverage on this Pulsar's multi-tenancy feature to help you. And okay, so that's what.
That's really I want to ask at the, when I start running the Apache Pulsar within my integrate my Java application, because I got a tons of experience to integrate my Java application like Spring, Quarkus, even Node.js with the Apache Kafka. And then when I start to running Apache Pulsar as the application side, and then I don't, like a little bit unclear to me because I feel like it's almost same thing as the application side. And then I really want to ask that question to Mary, and then Mary just really answered that the question here, the cloud name design, like a multi-tenancy, and then more cloud-based, and then support like the polyglot languages and runtimes.
Yeah, true, exactly, that's right. So we'll show a little demo too afterwards using the DataStax cloud platform to see how you can quickly set up a stream. In fact, in 5 seconds, you can set that up too. So, okay, and then another thing about Pulsar to want to bring up is it's not restricted to only writing Java client. You can do like C#, for example, Python, Go, and other community contribution languages, language bindings, such as like Scala, Ruby, and C++, and so on and so forth. So another feature too about Pulsar is that it also does not take care of all of the log messages. It's basically, it delegates it to Apache Bookkeeper to handle all of the log messaging. So in this case too, Pulsar, the broker, can focus on the message delivery, receiving the messages, and take care of message. You have deduplication, you have message retry, what you call like delete. You want to delete dead letter topics, all these things. Pulsar will handle all of these things and guarantee delivery of these things. But the thing is, though, with the large set of messages you have already sent out, basically Pulsar will work with Bookkeeper, and Bookkeeper will keep track of all of these messages too. It's a persistent message store essentially. So this will offload Pulsar from not having to worry about that, that part of the whole ecosystem. And then, okay, so I already mentioned too, another feature of Pulsar is that it has a guaranteed message delivery, which means that you producer sending out messages and you don't have to worry about it, right? Something goes wrong, and basically, your node goes down, something goes down, and once your system comes back up, it knows it, and Pulsar knows it, and basically it will deliver the messages for you. So don't even worry about it. The messages are guaranteed to be delivered. And then another feature of Pulsar is the Pulsar functions framework, which I briefly mentioned a little bit. So this actually helps you because as such, you are using an event streaming platform to construct a data pipeline, complex enough. But the thing is, with Pulsar function, you can use it to transform your data as it travels through the pipeline. So you don't need to kind of use any external framework to help you do it too. And then another really nice feature as well in Pulsar is the tiered storage offloads. So basically, it's that, as you know, if you're running systems in the cloud, you're being charged money, right, by the minute that you're using the resources. But let's say there's some messages that becomes cold. It's not active anymore. Basically, Pulsar knows it, and it will move it to offline storage, something that's a little cheaper to store, such as like S3 buckets or Hadoop like file system, things like that. And then it will take care of things for you like that. So then you can always like reserve the your storage in main area to be ready to process more urgent messaging too. So that's kind of summarizing the Pulsar as a tool that you can consider using. And this actually is another diagram to just shows you that Apache Pulsar is gaining in importance, and it is there are more and more people trusting it as well. So and all of these graphs, and it's kind of hard to see, but if you download my slide, you can take a look. I'm not kind of like making it up. Basically, the number of GitHub stars and number of contributors are rising for Apache Pulsar, this project. Oh, yes, and then now, we wanted to kind of talk about, I keep talking about event streaming, it's just doing event streaming, but the thing is too, is that with any applications, we're relying on a runtime. We still need to do, the building, all of these kind of infrastructural kind of things to make your application work. So what is better than having a framework just such as
Yeah.
Quarkus, right? So we have our Quarkus expert here to kind of introduce us that we can.
Yeah,
work
definitely.
with,
Yeah,
right?
thank you so much. Yeah, shout out the Quarkus stuff. How many people actually have some experience, the Quarkus hands-on experience work for?
Quarkus?
Wow, no one.
No one has
Wow,
worked with
yeah,
Quarkus?
fantastic.
Okay.
Yeah. So,
Yeah.
but I assume we have many Java developer here today. So we just introduced what is the best bet for the storming and streaming streaming computing with the Apache Pulsar. And the developer standpoint, so okay, how do I connect that Apache Pulsar, and how to send my messaging from Java application to that Pulsar, and how to consume the messaging from Apache Pulsar into my application using more RESTful API or any kind of reactive application. Mm-hmm. So there is always some concern or challenging for Java developer how to do that. So the Quarkus actually a Kubernetes native Java framework invented almost 4 years ago from Red Hat, and then a bunch of other committer and then contributor. So we almost arrived in Quarkus 3, and then one of the fantastic feature of the Quarkus actually provide the reactive programming. Because the Quarkus was born a reactive engine by default, which is Vertex and Netty. So can you please move on next slide? Yeah, sure. So one of Quarkus provides a lot of stuff, and then I'm going to just highlight one specific benefit here. So Quarkus allows developer unify just like a reactive and non-reactive application at the same time. So it's a little bit unclear, but the left-hand side is a non-reactive application, just like a Spring Boot request mapping, and then DI injection to develop a RESTful API. So literally, you're going to do the same thing with the Quarkus, but a little bit different annotation for inject dependency injection. It use like a inject annotation, and then you can produce like a text format, return type, or a JSON file, etc. And then, but you want to just rewrite this application for reactive programming to connect to like Apache Pulsar, or even event-driven infrastructure. How to do that? You just change the Maven dependency or grade module on your Java. For example, from just return JSON and now return not string type. It's more like a uni and multi based on a small write project. So you can keep maintaining your business logic, but you can change a small code change it enable your application turn into reactive programming. And then one interesting stuff, specifically Apache Pulsar. So Quarkus provides more than almost 600 extension. You can understand that maybe dependencies or gradual module. And then this is one of the extension is the Apache Camel. Apache Camel project is a provide enterprise integration pattern, like a data transformation and a connection between like a different system. And then the Apache Camel project and then extend that capability to communicate with the Apache Pulsar as well. So this is one extension. When you edit it, for example, this is a Maven project. You can edit this Apache Camel Pulsar extension into your Maven project, and then it allows the developer to connect to your Apache Pulsar server, and then consume and process event streaming data with the Apache Pulsar in the end. So, and then there are many variety of reactive capability here, like not only Apache Pulsar, like even Amazon Lambda for serverless application, and then Apache Kafka integration and the messaging broker, and then there are many kind of reactive capability Quarkus allows developer to implement on Java application. So this is a Quarkus for reactive programming. And then let's move on to a quick demo with a sample application.
Oh, sure. Yeah. Okay, so now, enough we're talking about all of these things. So you may be wondering, okay, the title actually of our talk is supposed to be processing trade matching engine data, but we thought it's important to talk about giving some basic information first, so that's why. Now we get to actually the crux of the matter. So basically, as I was thinking, right, some application that we can use, right, to illustrate, what that can be used for illustrating, what event streaming platform can help you with, right? So this is actually just an example, and basically, in my thoughts too, is that you'll be able to, because with event streaming platform, just like Kafka, we're talking about your message streams coming in, and then you're using topics, right, to kind of set up all of these, topics are essentially messages that are of interest, right, to you. So in this case too, in this example is basically about buying and selling stocks, right? How many of you actually are familiar or maybe working with stock market and doing stock applications? Oh, okay, so that's great. Maybe you can also give example or something. Because I myself, I worked at Chicago Mercantile Exchange for a little bit, so I'm somewhat familiar with futures and options type of exchange. And it's similar, right, to like stock buying and selling. So what I'm thinking is that you can actually think of using this event streaming type of approach to help with trade matching. Maybe you can also suggest to me if it's a good idea too. It's just more about experimentation because we're talking about fast streams, coming in. So we can actually set up a topic, right? The problem we're trying to solve is to basically have buyers and sellers. Each side is coming in from many buyers, many sellers, trying to either buy a stock or sell a stock. So they are all giving out prices, right? The buyer is going to want to buy it at the lowest price, as low as possible, whereas the seller is going to be trying to sell it as high as possible so they can get a profit, right? So that's the idea. So I'm thinking that, designing an application that basically have two topics. One topic, in the simplest case, okay. And then the simplest case is that you can have a topic of the buyer, basically you're collecting all of the buyer's prices and then coming in. And it can be coming from any time, essentially it's very asynchronous in nature. So it almost seems like it's a good kind of test case to leverage on event streaming, a pops up type of scenario in which, again, buyer, you'll be buying and they will be having price quote that comes in. This is just an example of a bunch of prices for, like, let's say for this stock symbol, GITS. And I don't know if there's such a thing called GITS, but I'm assuming, okay, let's call this fake stock symbol GITS. We're gonna interested in buying that. So we're proposing different prices that comes in. They comes in as stream. And all the stream is contained is basically one column of data. It's just the price. And then same thing on the other side of selling these the stocks. I want to sell it at as high as possible with the price. Many sellers wanting to send a price quote. So again, that comes into another stream that comes in. And then with this too, maybe we also need to make sure that these are being marked too. Each price comes in, maybe it needs to have a timestamp, so then you know when the quote is being quoted at that point in time. And then with that too, basically, again, this describes the problem is to try to find the best match within a certain time span. And I don't know, is it in the stock market, isn't it, you usually do price matching. Is it only like, you are kind of designating a certain time period you want to find matching? Anybody who's working on a trade matching type of thing? Yeah, I'm just kind of wondering, right? So, okay, so assume it is. Let's say that's why I call this a toy engine, because I don't know exactly how it works, but there are many rules to buying and selling too, but we make it as simple as possible. Just as long as, price comes in, one side is buy, the other is sell, then we want to immediately identify any matches. Once they are matched, then we'll say, okay, there's a match found, like that. So that's the problem we're trying to solve in here. And here is that it's just a description, right? It's a bit more of a functional, technical design level. And you can also suggest to me that the folks who are kind of trading engine expert here. But I'm just more thinking of, okay, in this case, I'm going to set up two topics. One is a buyer topic, the other is a seller topic. And it's kind of mimic the open outcry system, right? It used to be people yelling out their price, and then you collect the price, you enter into the system, but this is all digital. So some way of inputting all of these things. And basically, too, the two coming in, the topics, they're managed by, let's say I'm using Pulsar. The Pulsar broker is there to kind of be responsible for receiving all of these messages from both topics. And then in the meantime, too, in my application, too, I'm going to have two subscribers. One will be subscribing to the buyer's price topic. the other to the seller's side topics. And then I will be processing it. So in the bottom here, and there's basically that, oh, again, it doesn't show. It's kind of funny, this thing. But in any event, but the thing is, it's just supposed to be showing, right, underneath too. Once you collect the data, then you should be able to then have them kind of be processed, right? You're subscribing, you're consuming these messages. So once you get the data, then you want to start kind of essentially comparing the prices too, and then find the matches. So that's the idea of this application. But I do have to kind of admit that we just did not have a chance to actually work on implementing it. But this is just give you an idea. It's a high-level type of design of what it can, what the approach that we can use for designing and implementing this system. So, yeah.
Yeah, so there are actually two applications supposed to be shown here, the left-hand side, and one application, maybe multiple applications, consume and subscribe the buyer price topic. And the other application try to subscribe the seller price topic. And then you can actually implement that subscribing application based on like a Java.NET, or you can use Quarkus. And yeah,
sure.
Yeah, that's the example.
Yeah, that's right. Yeah. Okay. So I think we only have a little time left. But the thing is, too, before we get to that, I just want to quickly show you, because I brought up too is Pulsar, right? So let's take a look at Pulsar. How can we use it, right? I just want to give you this option and invite you to sign up for a free account. This will be the DataStax Astra managed cloud platform. And of course, if you want to use Pulsar, open source, you can always download it from Apache's website. But with that too, you have to set up everything. You have to launch it. But whereas if you want to use a managed cloud, please try Astra. So you go to astra.datastax.com, and you come to this screen, and you can then sign in. And the thing is, okay, that's fine. I'm going to re-sign in again, but just want to point out too at the bottom, you can see over here, to sign up for it, you don't need to give your credit card number. Just give your name, essentially, not even name, it's just your email address and your password. Then you are up, you get an account right away. And then what you do is that once you're in, so I'm going to show you now, you'll find that it's actually very easy to use. And so I like to encourage you to try event streaming out using managed cloud platform here, Astra. So, okay, so over here too, I won't get into all the details, but essentially too, you can set up different organizations, right? And you get like $25 per month, US dollar, to use this. And you'll notice too, as long as you're not using it for very heavy processing, it's pretty sufficient for you per month, right? To kind of set up any kind of projects that you want to experiment with. And so over here, you see that if you want to play around with our Cassandra, you can go to database side, but today's talk is about streaming. So we go to streaming, and you click on streaming, and over here too, we have actually, let me go to here. We created a new organization, because I have many other projects. So let's go to GITS, this organization. I have created, I'm sorry?
Yeah. Can you a little bit zoom in here? Okay, so maybe too small.
Too small, okay, sorry, yeah. Yeah, is it better?
Yeah, I think it's better.
A little better. Yeah. Okay, all right, so as you can see too, I have already created these tenants, but if you need to create it, it's as simple as going to streaming, and then you can say it's already organized by tenants. So you can then say create a tenant is essentially create your stream in there, in Apache Pulsar stream. You give a tenant name, and then pick your cloud provider, and then a region, and then that's all is needed. And it will also show you, let's say over here, if I say, okay, GITS 2 or something, and then I Google Cloud, and then this is Asia Pacific, so I'll pick Australia as the region. And as you can see over here, the operation cost too is very reasonable. There's 13 cents, right, per a million messages, for example, then it's very affordable. And when you click create tenant, it will be created right away. So then immediately you can try that out. But I won't kind of create it now because I already have created one called test seller and a test buyer. So those are my topics that I describe about receiving, right, buyer's quote, buyer price quote, and also seller's price quote. But let's say click on buyer. So once you created a topic, you go in here, a lot of these things are already set up to guide you to kind of do further work with it. For example, you go into here, right? You can connect to your tenant in many ways. As I mentioned, it works with Java, Python, Golang. All of these are listed here. And there are more, too, that aren't even listed here. But by using this portal, you can actually, let's say, we're Java developers, we go to Java. And if you click on it, then below in here, it will show you how you can use it, what is the Maven directives for you to connect using Maven, And also like Gradle too is supported. And then you may be wondering, how do I write a producer? So you go to the producer code, it gives you a very simple example of writing a producer is as simple as in your main, right? This is again just illustration. So you just need to set up Pulsar client builder, essentially set up your client handle. And then of course too, you have to set up the token with it. And all of these too, by the way, you can, once you set up your cloud, you should be able to go to this, why is it not showing? But there should be in Connect, oh, here, sorry. If you go to the Connect tab, there's a download client.conf. That file will contain your broker URL, all of these specific configuration for your particular setup of this tenant is in there. So you can fetch all of this information from there.
Including access token key.
Yeah, the token as well. That's right, that's where you get the token. So again, we go back to our Java code example, and then you want to write a producer. It's as simple as just set up your client handle and the token, right? You get it from that client.conf in here, replace it with that, and then .build. Once you get the handle, then you can then set up your producer. Just do a client.new producer, associate with the topic. You don't need to, well, that's right. So you can create your topic too, or if you don't specify it, if it hasn't been created, it will create for you too for the topic. Then do a .create, the top, then the producer will be created. Then you are ready to send messages. You can then do a producer.send. It's as simple as that and pass in a string, but you do need to convert it to byte array before it can be sent to. That's kind of like by default, that's what it is. Otherwise, you can use Pulsar schema in order to use your specific type too. So and I won't go into all the details on that, but
so one example is the Quarkus you mentioned earlier. The Quarkus Apache Pulsar extension actually allows you to use the Pulsar client as well. So you if you want to copy this kind of thing, example, and into Quarkus application as a main application, it's really working. Even though there are some of the warning messages, like some security stuff, but this example is actually working on Quarkus when you're using Apache Pulsar extension.
Yeah. Okay. Thank you. Okay. So that's an example too of producer. And likewise, if you want to know how to do consumer, it's also listed out for you too over here. But I won't kind of step in because it looks like we may be kind of running out of time. But likewise, too, for doing consumer, it's more like you associate your consumer with the topic and also a subscription name, and then you do a .subscribe. Then you're ready to listen for any messages that goes to that topic. And then all you need to do is basically then you need to receive it when you have messages that comes in. And then you can acknowledge it. Once you acknowledge the message, and then it can be removed too. But not exactly like all removed. It just means it removes from the broker having to worry about sending it again, kind of like that. So that's kind of as simple as that. It's how you can get started with Astra streaming, essentially Apache Pulsar. And I do have to say that it helps too. If you're learning everything, you let the cloud manage all of these things for you rather than you installing everything. And then you can still also use a command line. There's also Pulsar client command line that you can use for interacting with your Pulsar server as well. And then, okay, so other things too, for example, you can use this interface to set up your topics, set up your namespace, and there's also building a data pipeline, the source connector. You can also create new sources in here. For example, this over here, you can immediately use a namespace and the type of, actually the source, as you can see, there are plenty of types of source connector that are pre-configured. Although a lot of them are still experimental, but you can use it right away. Like there are people that are using IoT applications, let's say with MQTT, it is there too. They're already source connector with that, right? That's just one of many examples in here. Kafka, that's also available as well as source connector. And then you can also use a sink over here to create a sink too. Likewise, the sink is where you collect all of the transformed data, right, from your source. And so over here, if you look into it, you can also have use some of these pre-configured source connector that's already available. There are also a whole bunch of these too. So they're all ready for you to try. So I'd like to encourage you to give this a try. And there's also Pulsar functions in here as well. But functions is a different topic too. Maybe I'll do a talk on that next time. So yeah, I think it's probably we kind of running out of time. And again, right, let's go back to over here and give you some information on how you can stay in touch with us, right? And okay, so okay, I'll let you talk
so one thing is if you are interested in Quarkus, because you don't have any experience in Quarkus and how to develop your Kubernetes native Java application, like a GraalVM, and then like a bunch of the reactive stuff, and then how to make a better application, like compared to Spring Boot. Yeah, I got a 100% heavy demo session tomorrow, 4:30. Yeah, feel free to join the session as well. And move on next, please.
Okay. Yeah. Okay. This one is just a page on all of the links to how you can look up information on Pulsar and the DataStax event streaming Astra platform too. And here too, I also have a Twitch stream. So as mentioned too, we will be doing more kind of demonstration on the Twitch and get more into actually hands-on too, if you like to follow me on my Twitch. And we also have.
Yeah, here's the QR code for Quarkus community. Yeah, there is a web page and a Julep chat. You can ask any kind of stuff. There are many Quarkus experts, including me. And then there are a YouTube channel and a GitHub repository. Yeah, feel free. Use that and then ask any kind of question. We are more than happy to address.
Cool.
Right?
Yep.
And the last thing, another QR code by my YouTube channel, and I put on the hundreds of the video, like a tutorial, not only Quarkus, Spring Boot, and a cloud, and a serverless, and a service mesh, a variety of the topic and tutorial and insight. Yeah, feel free to subscribe and ask any kind of question, and then happy to communicate with them after summit.
Okay, great.
That's it. That's
Yeah.
all we
Thank
have
you.
right now.